Hello everyone, welcome back. So now we're going to talk about the emitter and how we're setting it up, and the main thing that we want to look into is the variation of these debris. Now they're not all the same. Each one is, we have a set of pieces that we're switching in between. And first of all, let's take a look at the points. So we have this velocity vector from the geometry, so we're keeping that, and I'm adding a p-scale attribute with this variation between 0 and 0, 1 and 0. Let's set this to 1, this to 2, and this to 1. And then angular velocity is a w vector, and I'm using I'm setting it to this range, so we can add more if we want them to spin faster. And I'm deleting all the attributes except these. And then I'm generating an attribute called PID, and this expression is basically giving me a random value that goes between 0 and 11 or 0 and 10. So you can see this will give me between 0 and 1 value, and then I'm multiplying that by 11 to get a range between 0 and 10. So each point is getting an integer. And then here I have a box. I'm converting it into a sphere, and then I'm scattering points. So this is my geometry, and then I'm assembling that, creating a packed geometry, and I'm creating a name attribute on each one of these. I actually don't have to do this. So I don't have to do this, but what I'm doing here, I wanted to create an integer that matches the name, the last digit of the name. So I'm looping over the name attribute, and I'm removing all the first 5 characters and keeping the last one, and then converting that string back into an integer using an A to A. So that's what I'm doing here, and that's going to give me the last string, the last value of the string, and I'm converting that into an integer. And then I'm using an expression to remove all the pieces except the one that has except the one that matches this point. So what we could do is we can loop over each point. To make it simpler, we can loop over each point, and every time query the PID number, and then isolate a piece that has the same value. And because we numbered them, because we have piece ID here, we can just use that to isolate the correct piece. But here, because we're using packed primitives, let's take a look. Because we're using packed primitives, it works the same as if we're deleting points. So by just removing everything else except the one that is equal to this value, we're only keeping 1 point. And then I'm using a center, center position, and it's set to $CX, CY, and CZ to set this back at the origin, because we have to have the debris set to the origin. And what I'm doing next is this ID, this piece ID, I'm using a stamp function, and we're looking up every attribute from this. So after we copy them, during this process we ask each point, what is your value, and then we go run this expression, run this function, and then give it back a geometry to work with. And the way this is working is by turning on stamp inputs first, and then the attribute that we want to stamp, and that's PID. Okay, and in here we're going to use a stamp function, and we're going to look up the ID attribute on this node, and we need to pass in 1, and that's going to change based on each point, and this will switch the input, and then we get variation on each point, and that's how it works. So this way we can stamp randomize the the debris. There's other ways as well that we could do. We could add noise, for example, to deform the geometry, but that means that we have to have unique geometry, a lot of unique geometries, and in this example we just have 10, or how many? Yeah, 10 pieces, and that's how many copies we get. So it's going to be very, very efficient to have 10 pieces and then only instance these. So that's how the emission debris emitter works. Thank you guys for watching, and see you in a bit.